Alright, so today we're going to be talking about algebraic vectors. Okay, vectors can be represented in several ways. We've talked about it already, geometrically. Okay, where you have an initial point and a terminal point given, the component form, okay, which is when we were finding our components, which is a vector. Vector is a directed line segment from origin to a given point. Unit vector form, okay, which is pretty much just taking our components and putting a I and j next to it. Okay, we also call that a linear combination of unit vectors, and then by magnitude and direction. Okay, and so we're going to talk about some of these new ones today and show you how to find them algebraically. Okay, so when given an initial point, x1, y1, and a terminal point, x2, y2, the component form of a vector is equal to just x2 minus x1, y2 minus y1. Okay, note the parentheses for the initial and terminal points because they are coordinates. Okay, note that though when you're writing the component form though for a vector, you need to use the arrows. Okay, so let's use this example to find the component form given the initial point and the terminal point. Okay, and so what I like to do here is I'm just going to label this. I'm going to say x1, y1, x2, y2, and then now all I'm going to do is I'm just going to plug it into my formula, right? So my formula, okay, so what is x2? x2 is, it's 3, x1, so it's x2 minus x1, so x2 is 3, minus, and then a negative 4. Remember that minus sign comes from the formula there, parentheses, and then now it's y2 minus y1, so y2, negative 5, y1 minus 2, and now let's go ahead and simplify. So minus minus, that gives you plus, so 3 plus 4 is going to give you 7, and then negative 5, negative 2, a negative 7, and so there you go. That's your component form for vector AB. So very self-explanatory there, right? You're just going to take the 2 points. You're going to label one, the first point x1, y1, the second point x2, y2, and you just plug it into your formula there. Okay. We have talked about this a little bit. Vectors have both magnitude, how far they are going, and direction, where they are going. Okay, we've discussed that a lot. And so we are going to then go ahead and just talk about it again formula-wise. So again, our notation for magnitude is just absolute value. So when you see a letter in between two absolute value signs, okay, this should have it's a typo. Should have that arrow over the top like that line with a half arrow over the top. So if we wanted to find the magnitude of AB with the initial point negative 4, 2 and the terminal point 3, negative 5, okay, so again, we're going to take its components. So we found this in the problem before, right? So the components for AB were what? Were 7, negative 7. I don't know why I'm doing a parentheses. Sorry, you don't want to do a parentheses there. And so then to find the magnitude, remember your notation here, it's going to be absolute value. We're just going to do this. We're going to take both components, square them, square both of them, add them together, and then take the square root, which on the calculator, let's do that. Very easy to. Sorry, that's the glare there. So we're just going to do square root 7 squared plus a negative set. Put the negative 7 in parentheses, because if you don't, the calculator will think that that is a negative 49 when it's not. We hit enter and we see, okay, 7 root 2. And so that is the magnitude of AB is 7 root 2. Okay. All right, so if a vector V equals its components A and B, then the direction of the vector V or A equals tan inverse of B over A. Okay, and now these are the quadrants, right? So quadrant 1, I'm never adding anything. For quadrant 2, quadrant 3, and quadrant 4, okay, quadrants 1, 2, and 3, and then quadrant 4, I'm going to add 360. So 2 and 3, I'm going to add 180. Quadrant 1, I'm not adding at all. So direction is measured counterclockwise from the positive x-axis. So it wants us to find the directions of the vector. Okay, so to do that, we're going to do this. So theta is equal to tan inverse. Remember, this is A, this is B, right? So it's just B over A. Okay, and so then it's going to look like this. So then you're going to have this. You're going to have now tan inverse of 7 over 2, which then we have to have our calculator for. Okay, we have to have our calculator for, so we're going to go tan inverse of 7 over 2. And we're going to round to the 10th, so I'm going to say 74, so that's 74.1 degrees. Now, how do I know that that is correct for the direction? Okay, like how do I know tangent's correct there? Well, look at your ordered pair. What quadrant is this in? This is in quadrant 1. Okay? And so, since it's in quadrant 1, look at our rule up here. We don't have to add anything to it, so we know this is correct. Now, I want you to recall, though, okay? It's like having a compass here, right? Remember, east is 0 degrees, or if we're approaching it back close after doing one rotation 360. 90 degrees is north, 180 is west, and then 270 is south. Okay, and so we're going to go ahead and write this answer like this. This is how I want you to write it when you're doing direction. Okay, you're going to go, because that 74 degrees is closer to north, we write it like this. We do north 74 degrees, 74.1 degrees east. And that right there is your direction. Okay, sorry, I'm squaring all the correct answers, right? So now it asks us to do, okay, find -6, -4. So same thing again, right? We're going to do tan inverse of B over A. I already showed you the first step up there on top, so I'm going to skip it, and it's going to look like this. It's going to be now -4 over -6. And so let's go ahead and plug that into our calculator. So tan inverse. Okay, well, -4 over -6 is actually a positive 2 over 3. So let's go ahead and do that. And so when we do that, we're going to get now 33.7 degrees. But here's the deal, okay? Look at the components of this vector. What quadrant is this in? This is in quadrant 3. So I need to have an angle. I need to have an angle somewhere in between 180 and 270. And so then what I'm doing then is I'm taking this 33.7 degrees and I'm adding 180 degrees to it. Okay, and so when I do that in the calculator, 33.7 plus 180, I end up with 213.7 degrees. Okay, and so when we write that direction-wise, now we ask ourselves, okay, is that 213 closer to 180 or is it closer to 270? And in this case, it's closer to 180, and so we're going to write the direction like this. We're going to say west, 213.7 degrees, south. And there you go. And so that's how I want you guys to do direction. That's how you determine direction there. Okay? All right, almost done here. Like I said, not a super long video, okay? All right, vector operation. So we used geometric last week to find the result and to add vectors here. So now we're going to look at it algebraically, okay? And so again, it's actually even simpler algebraically. So let's just say we have vectors u and v, right? So vector u is going to be a1, b1. Vector v is going to be a2, b2. So when you're adding two vectors together, you just add the same components together. So it would just be A1 plus A2, comma, B1 and B2, because A1 and A2 are your horizontal components, B1 and B2 are your vertical components. Same thing with subtraction. Okay, you just take your two components, the two same components, and you subtract them. You take the two same components and you subtract them. And same for multiplication. Multiplication, if we have a scalar on the outside here, a number, we just distribute that to both components. Okay? So let's go ahead here. We've been given a couple of vectors. We've been given W, Y, and Z, their components. Let's go ahead and let's add a W plus Y together. Okay, so it's going to look like this. So W is a -4, 1, plus Y, which is 2, 5. And so then I'm just going to write it like this. I'm going to take their same components down here. So it's going to be -4 plus 2. And then 1 plus 5. And so the component of W plus Y is now just -2, 6. And so very simplistic there. Okay? For Z minus 2Y, it's going to look like this. Again, vector Z is -3, 0, minus 2 on the outside here. And then vector components for Y are 2 and 5. So what I want to do first is before I go ahead and add this exact same components, I've got this -2 on the outside, I need to go ahead and distribute it through. And so now I'm going to have something that looks like this. I'm going to have -3, 0. This now becomes a plus because this -2 went through to the components of the second vector. And so you write it like this. You're going to say -4 because -2 times 2 is a -4. -2 times 5, comma, here is going to give you a -10. So now we've simplified the 2y vector there, and now we can go ahead and just combine these same components. So we're going to have -3 minus 4, comma, 0 minus 10. Close that arrow there, and now just go ahead and simplify. And that's going to leave you with a -7, -10, and there you go. That is your doing adding, subtracting, multiplying there. That's your vector operations. Okay? So when we write something as a linear combination of a unit vector, or some of what we call sum of unit vectors, very simplistic. All we're doing, literally, guys, is we're taking our components, and whatever it is, we're writing an I and a J next to it. Okay? That will be way more important going forward when we gotta get into dot product. I think dot product's on Tuesday, or yeah, it is on Tuesday. We'll talk about the basics of it, but if you take calculus and anything above, it'll be a lot more important to understand sum of unit vectors. For us right now, we just need to understand that, hey, given the component form, we can write it as a sum of unit vectors, which is literally just taking, we don't even change the signs. Look, it's just 3i minus 4j. Okay? So that is it for today. Not a super long video for the notes. Okay, should be pretty basic. And again, like I said, I'll have the homework posted as well as along with the video ahead of time. All right. All right. Thanks, guys. Have a great day, and I will see you in class on Tuesday. Talk to you then.